This fourth passage is a research passage, and some students were testing the effects of mass and length on a pendulum. Now, a pendulum was constructed with a ring stand, and they tied a string to a mass. And what they were calculating was the period, which is the amount of time required for the pendulum to complete one cycle, meaning swinging back and forth once. So the first experiment, what they did is they had pendulums of different lengths with the same 30-gram mass, and they determined the average period based on 10 cycles. And they recorded that in this graph right here in figure 2. In experiment 2, they had pendulums with different lengths and different masses. So in experiment 2, they were not only changing the length, but they were also changing the mass to see if that affected the average period of the pendulum. So number 13 says how many different pendulum lengths were tested in experiment 1. Well, the results of experiment 1 were in figure 2 here. And there's 10 points in this graph right here. So because there are 10 points there, and the length of the pendulum, you can see there's 10 different points along the x-axis. That must mean there were 10 different pendulum lengths. So number 13 was C. Number 14 says based on figure 2, a pendulum having a length of 285 centimeters and a 30-gram mass, which they all did in figure 2, will most likely have an average period closest to which of the following. So we're going to look at the line on figure 2 at 285, which isn't on the x-axis, but is right in the middle between 270 and 300. And you go up to the line, follow that across, and it's somewhere around 3.4 seconds for its period. So number 14 was J. For 15, it says the arc-shaped path of a pendulum is shown below. Okay, so when this pendulum swings, it's going to fall down, and it's going to reach its low point. And then it's going to keep moving, and it's going to reach its high point. So think of something swinging and what that motion would look like. It says, during a cycle, will the mass most likely be moving the fastest at the high point or at the low point of its path? Okay. A says at the high point because the mass speeds up as it drops. Well, when it's at the high point, it's not falling yet. It hasn't moved. It's really actually still at the high point. For a split second, it's still, so it's not moving fast at all. B says at the high point, because the mass slows down as it drops, which it can't slow down as it drops, gravity is going to cause it to speed up. C says at the low point because the mass speeds up as it drops, which is true, and slows down as it rises, which is also true. D says at the low point it's the fastest because the mass slows down as it drops. The mass won't slow down as it drops. Gravity will make it speed up and accelerate. So that one was letter C. For number 16, it says, based on experimental results, to increase the average period of a pendulum, the student should do what? So there's a few places you can look here. You can look at figure 2 and see that as the length of the pendulum increases, or as you go right on the x-axis, you increase on the y-axis, meaning as the length of the pendulum goes up, the average period goes up. You could also look in experiment 2 and notice that when they had a length of 15, regardless of what they did with the mass, they had a period of 0.8. But when they made the length 30, the average period went up. So changes in mass with the same length had no change. Changes for 15 to 30 centimeters in length did have a change. So it looks like based on those two things, figure 2 and this table here, the longer the length, the longer the time of the period. So you would want to increase the length of the pendulum for it to have a longer period. And the last one, 17, based on figure 2, what was the difference in length between the pendulum having an average period of 2.2 seconds and the pendulum having an average period of 1.1 seconds? So you need to find those 2 points. An average period of 2.2 was right about here, and an average period of 1.1 was right here. So you look at the lengths for those 2 points. There are 120 and 30. We want to find the difference between those two numbers. That's subtraction. you would take 120 and subtract 30, you would get 90 centimeters. So 17 was D.